All right, y'all. I don't know if my brain just broke while doing chemistry homework, but I just kind of rethought about a way that the number line works in terms of finding the difference between negative numbers. So I'm gonna go over to this miniature whiteboard that I have and kind of pitch my, I wouldn't even call it a hypothesis, more of just like a questioning of how numbers actually work in terms of fixed variables versus like the true difference. So let's go over to the whiteboard. All right, this really tripped me up while doing chemistry homework. So I'm actually gonna reference the exact numbers just so I can keep my normal flow. So an iron sample starts off at 95.3 degrees Celsius. So let's put that on a number line. And then this is negative 95.3. And then it ends at 25.6. So that's the T final. This is T initial. So the original equation was T final minus T initial. Those values, like I said, were 25.6 minus the 95.3. So that was the chemistry context of this. Let's get into the mathematics of it. So right here you have negative 95.3. Here's 0. And you have 25.6. So I got in this really weird headspace of doing math. It was like an ancient headspace almost of, okay, here's 95.3, here's 0, and here's 25.6. And subtraction is the difference of something. So why don't I add a positive 95.3 to this? And it'll bring it to 0. So 95.3 negative plus 95.3 positive is going to equal 0. And I still need to get to 25.6 because I'm finding the difference of these two values. So I already offset it to 0, so I need to do plus 25.6. Okay, let's solve it. So 95.3 plus 25, 10, 12, 120.9. That's not true. That's not how we do math. But is it not the difference between these two values? That's how you get the value. So if you subtract this from 25.6, is going to equal that. So that would be, but yeah, what we do in mathematics right now in order to visualize this, we take these two values and we combine them together. So let's just take this segment right here and isolate it. So you have 0 to 25.6. And what we do in math is we decide to bring this over here. So like that. It's hard for me to explain exactly what I'm talking about. It looks something like this. So we're just taking the compilation of those two. This is negative value, of course. So the 25.6 minus the 95.3 is equal to 60 something. Because it's just going to be 25.6 minus that 95.3. So it was equal to, let's see, 7. Anyway, I hope y'all were able to kind of see what I was visualizing with the number line. So I feel like my math state almost reverted to like that of a child. So it's like, oh, you have negative 95.3. So how do you get it all the way over here? Oh, you're gonna add it. So you just take, so how do you get rid of this negative 95.3? You add a positive 95.3 to get to 0. Then you do plus that. So why is that not the true difference? Why is that not what we find when we subtract something? Why is it that we have to take, like I said, this segment, and then we have to drag this negative 95.3 all the way over? I feel like a crazy man talking, but I've never been in this headspace before. It's very strange. It's like you combine these two in normal math, but why? It has to be something else that made it this way. Because the true difference is different than the difference that I'm thinking of is different than the true difference, which is just combining these two values. And like I said, those two combined equaled that negative 69.4 or 0.7. 69.7. But yeah, hopefully y'all are able to visualize what I had in my head, and hopefully I can get somebody to explain exactly what's going on here, why we combine those two negative and positive number lines instead of just looking at the true difference. Maybe there's some kind of value I'm not aware of, or some kind of theorem that I'm not aware of that explains this, but it looks like the number line distance, basically, like the number line distance is different from what we call the difference in subtraction. So hopefully y'all got something out of this. I hope it didn't confuse anybody, because I got very confused. It was very strange having done normal math my entire life, and I'm doing a chemistry problem, and all of a sudden my brain reverts back to like a stupid version of this. But I kind of learned something from getting in that stupid state. So that's the video. I hope y'all kind of got in that same headspace that I was talking about, but it was weird. So if there's any calculus people out there that can explain exactly what's going on here, I'd like to know. So yeah, thank you all for watching. Hey y'all, so for lack of a better term, I don't know if I was like tripping basically and just like made math really stupid, but I feel like I kind of came across something with this. So I don't know if there's some research I'm unaware of that I can look into to see exactly why I tripped up so hard on this. But it feels like I kind of unlocked something that is probably explained at a higher level of math. So if y'all have any research papers that you can drop in the comments, or if I'm being stupid and you want to explain away as to like why the number line does or doesn't work in terms of like what we actually use the subtraction or difference in terms of like actually having real objects that we subtract from. I mean, obviously I know that 20 minus 90 is going to be negative 70. Or 20 plus negative 90 is going to be 70, of course. But if you look at it from the context of negative 90 and you want to get it to 20, why are we not adding 90 to that negative 90, getting it to 0, and then getting it to 20, which would be 110. So, and obviously I know that that's not how we do math. It's weird. So, you know, 20 plus negative 90, like I said, it's going to be negative 70. Think about it from the context of negative 90. Negative 90 plus 110 is going to be positive 20. Don't know how else to explain that.